So in this lesson, which is the Define One Policy lesson, we're just going to describe very briefly one policy, specifically where Cisco Ice is involved. Ice is going to combine all of the policies, the security components, the security services into a single platform, which is the Cisco Identity Services Engine. And that is a centralized security policy management platform. It's going to unify, it's going to automate all of the security access control. It's going to allow us to enforce our role-based access to networks and network services and so on. So we'll take a look at the general ICE architecture here, which will include ICE personas, and we'll take a quick look at the ICE licensing models and identify what the purpose of the ICE licensing is, all right, and how we can activate some of these features in ICE based on those models. As I've mentioned in a couple of previous exercises, Cisco Ice is basically an appliance. It's a software application running on a virtual machine, running the ICE software. It can be a physical appliance that you can purchase from Cisco, or you can choose to deploy it in a virtual machine environment in your VMware architecture. There are three major collections of ICE services that get organized into these things called personas. Those personas are responsible for different functions within the ICE architecture. And they can be co-located onto a single node, or they can be distributed for load balancing purposes or whatever across multiple nodes in the domain. So we're going to talk a little bit about what these three personas are. The first one is the policy administration persona. This particular persona is the interface for the configuration policies. The persona is used to control, well, actually, before I go into that discussion, the persona is the control center in the Cisco Ice deployment. It also controls the licensing. It contains the user interface, and the administration persona is also responsible for pushing out configurations to other nodes if you have, say, a redundant distribution design or a distributed design model. Nodes that implement the policy administration persona are referred to as PANs, all right, or policy administration node, all right. The next persona that you see on here is what we call the PSN, the policy services node, which implements the policy service persona. This persona is the engine that makes all of your policy decisions in your network. The persona is the main runtime engine, and it is going to enforce all the policies that you're trying to implement for both your wired and wireless devices and endpoints. It also operates and functions for other components, like it processes all the network messaging that pertains to the ICE deployment itself, things like DHCP, Cisco Discovery Protocol, NetFlow, Radius, and so on. And again, like I mentioned before, any node that decides to implement the policy services persona is referred to as a PSN or a policy services node. Then you have your policy service, management component, the monitoring and troubleshooting node, which is MNT. And that's basically the, and this would normally be co-located on the same platform as maybe a policy service persona or a policy administration persona. But this is the platform that's going to provide things like monitoring, syslog information from it'll collect all of the syslog information from your network attached devices and so on. And then you have your inline posture node. The inline posture node is there predominantly to enforce policy. And we'll get into a little bit more detail on that component in a little bit. How do all these personas work together? Well, first, as an administrator, you're going to log into the PAN, where you will configure Cisco Ice with the deployment infrastructure and all of your deployment policies. Once the policies are completed, those policies then get synchronized to the PSNs in the distributed environment, and they get audited to the MNT. A user is then going to connect to a network attached device, which is usually a switch or a wireless LAN controller. That device is going to generate a radius authentication request from that network attached device, and then the radius client, and then that's going to get sent to the PSN, which then conversely gets sent to the radius server, if that makes sense. The PSN always checks the authentication rules. It queries the appropriate user databases depending on how you have your device set up, whether you're going to an internal Active Directory database, a LDAP database, or whatever, to check all the authentication credentials. Based on the response for the user database, the PSN then will locate the correct authorization profile that is to be applied to the particular user. Those policies, the policies can include lots of different components, but they can include downloadable ACLs, VLAN assignments, voice domains. If you're using Cisco TrustSec, it can include security group tags, and so on. So that's what's going to be sent in response to the network attached device. The NAD will action those policies, meaning that it will take those policies and apply them by applying the downloadable ACLs, the VLANs, the security group tags to the user's traffic, and it ties that information to a session number. The NAD then also sends radius accounting messages to the PSN, and the PSN then correlates those messages, forwards them over to the session audit and syslog components that are part of MNT. So you kind of see that whole process documented here in this particular diagram. For specific services, things like radius, you want to point the NAD to the IP address of the ICE, because even though there is some back-end integration, ICE is really the all-in-one platform that handles all of this information. And we'll also point the wireless LAN controller to the IP of the ICE as well for the same reasons. So we talk about ICE, the Identity Service Engine, quite a bit. What other capabilities does it have? Well, it has business policy enforcement. It's a rules-based, attribute-driven policy. So you're creating these rules. Some of them, there are some default rules that exist, but you can also create custom rules that are driven by attributes. And attributes meaning like, is it a Windows 7 machine? Is it a Windows 10 machine? Is this person accessing the network via wireless client? Are they accessing the network via wired client? And what that allows you to do is create these business relevant access control policies. This gives you the ability to integrate with multiple external identity repositories. I mentioned this before. We can talk to Active Directory, we can talk to Radius, we can use one-time passwords, we can use token-based authentication with RSA, we can talk to LDAP, and we can implement the use of certificate authorities for authentication and authorization. It also provides for access control, a whole bunch of different access control options with like downloadable access control lists or DACLs, VLAN assignments, URL redirects. We can do named ACLs, we can use security group tags, which is all the things that would work very well with the rest of our infrastructure. There's guest lifecycle management. We talked a little bit about that. Remember, this is part of the incorporation of ICE. So we have a streamlined option for providing guest lifecycle management. Hotspot features, sponsored guest access, self-service access, and lots of different types of workflows that allow us to manage the guest access. Device onboarding, if you're doing things like BYOD, there are all kinds of pre-programmed out-of-the-box workflows that walk users through the onboarding process. It actually gives the end user their own self-service portal so they can add and manage their own devices, assuming that we have the policies and the policy enforcement configuration set up. Of course, full support for AAA, authentication, authorization, and accounting. It acts as an internal certificate authority as well. We can do device profiling. Is it a camera? Is it a printer? Is it a smartphone? If it's a laptop, what kind of operating system is it running, and so on. We can do posture assessments, policies that include things like checking for the latest software patches, looking at antivirus definitions, anti-spyware packages, making sure that files have the appropriate version, timestamp, looking at registry information, registry keys, registry values, looking at specific applications. And it does actually have the ability also to do remediation. So if for some reason something is not appropriately managed, or it doesn't have the appropriate posture, we can go through the process of remediating that issue. It has Cisco PX Grid and ICE ecosystem capabilities. PX Grid, probably something we're not going to spend too much time talking about in this class, but it is a context sharing platform within Cisco Ice that gives us access to contextual data. And that would also be accessible from external and internal ecosystem partners to identify the capabilities of devices across the network. All right, we have integration to SEIM tools. We have monitoring and troubleshooting capabilities, of course, and so on. All right. With wireless, almost always there comes a need to include access for visitors, contractors, and so on. So the guest workflow that is built into ICE provides the ability to manage that process quite easily, actually. There are 4 basic guest flows that exist. Most likely the self-service is the one that you're probably going to end up using the most, but there's a hotspot guest flow. Guests actually get network access without requiring usernames or passwords, basically just a non-credentialed access because the user doesn't have to have any credentials in this case. There's a self-service guest flow. Guests actually provide information in a registration process on the web. They're then sent a username and password over email, or they can get it through SMS, or they can actually see it directly in real time on the screen, and then they can use that information to provide their credentialed access to the network. You have self-service sponsor approved guest flow as well. Very similar to the self-service, obviously. The guest user registers on a web page. After the registration, though, a message gets sent to the sponsor asking if it's okay to give that particular guest credentials. So there's just a secondary step that takes place. And then you have full-on sponsored guest flow where the guest asks the sponsor to create them an account. That's also a very common approach as well. All right. What does that look like on the interface? This diagram kind of gives you, although it's not really that detailed, it does give you a little bit of a peek as to what that would look like. All right. This is ICE version 1.3. The guest buttons allow you to, well, the guest button itself, with the one that you see highlighted there at the top right of the screen, that's going to get you to an overview of the steps to require, the steps that are required for guest access, the guest portal to create the guest workflows, the guest types, sponsor groups, etc., etc., etc. We won't get into all the specifics here, but okay. You'll also notice here that we see the option for personal device portals. Cisco Ice provides actually several different web-based portals to allow employee-owned personal devices, what we call BYOD. All right. Now, these devices don't actually participate in the guest or sponsored portal flows. They're kind of a separate setting, but there are a couple of different portals that allow us to configure this. There's a BYOD portal, bring your own device, that enables employees to register their personal devices using a native supplicant. There's client provisioning portals that actually forces employees to download a posture agent. That would be like Cisco AnyConnect typically. There's an MDM portal for mobile device management systems, so that enables employees to enroll their mobile devices to an integrated external MDM system. And then there's a My Devices portal. That's going to enable employees to add and register personal devices including ones that don't actually support all the native supplicant provisioning that we talked about previously. So there's a lot of different options, Okay. As I mentioned before, ICE can also act as its own certificate authority. This is with ICE 1.3 and above. You can create an internal certificate authority. That's going to simplify certificate provisioning and deployment for your BYOD devices and your MDM deployments. The internal CA capability obviously is going to eliminate that complexity required with integrating your external PKI certificate authority infrastructure. And just reduces one more moving part from the overall design. It's still going to require some configuration, obviously, on the ICE. The management console is what allows the administrator to delete an endpoint, delete a certificate. Once an endpoint does get deleted, if there is a certificate tied to that endpoint, that certificate will be deleted as well. And we can also revoke certificates, we can view certificates, and so on. So ICE can be deployed as a self-contained CA, or it can be integrated into an existing enterprise certificate authority environment if you still require that. ICE also responds or provides OCSP options to check the validity of the certificates as well. So as you can see, it's a pretty powerful platform. All of these features are kind of a la carte. You have to purchase licenses to provide access to each of these services. As you can see here, the base license, that is really the main license. That's what's going to give you 802.1x access, TrustSec, AAA functionality, and so on. If you want to add the BYOD with the built-in certificate authority and the profiling feature, you need to add the Plus license. You also need a license for the number of endpoints in this particular case. The Apex license is going to add the mobile device management, the posture compliance piece. AnyConnect Apex license is an add-on Apex license to support AnyConnect as your posturing agent, which is what a lot of people will use. AnyConnect is not just a VPN client, provides a lot of functionality. You'll need a mobility license, in combination with the base, the Plus, and the Apex license if you want to add endpoints as well. You need the mobility upgrade license to add mobility for wired users, and then an evaluation license can be used. It provides functionality for up to 100 endpoints, full functionality, meaning that everything would be licensed for up to 100 endpoints for 90 days. All right, but base licensors are definitely required to use the services that get enabled by Plus or the Apex license. You do not need a Plus license, by the way, to have an Apex license or vice versa, but because there's really no overlap in their functionality. All right. Let's see. There's a window, obviously, to upload the licenses. It's under administration. Go to system, go to licensing, and you can upload the licenses. All right, so very, very short chapter. We talked about ICE as a service, ICE as a platform, network attached devices and how they connect to the various personas to provide different services, policy enforcement, guest access, internal certificate authorities, profiling, BYOD support. We have guest flows for several different options: hotspot, self-service sponsored, and full sponsored access. And the internal certificate authority functionality allows support for BYOD and mobile device management. And then finally, the licensing model that we talked about. Cisco does tend to change their licensing quite a bit and the licensing models quite a bit. So I would always suggest that you always go out to cisco.com and check the latest information with regard to that. So that completes this lesson. And in lesson number 4, we're going to continue with this topic here and talk about the Cisco One Network, which will wrap up this whole unified architecture concept that we've been talking about in this module.